Hello and welcome back to my numeral system tutorial series. That's what it is. Uh, this is the second episode. We go over binary today and how fitting, one of the most infamous numeral systems in my opinion. And right below binary there is binary and binary. Binaryception. But let us get off. So binary is base 2. And as you can see already on the left, normally binary comes in bytes, which are 8 bits. A bit is 1 digit. And there's also nibbles, which are 4 bits. Just a play on words, of course. And of course, base 2, binary is base 2, so it has the same system as the decimal system, except of course, base 2. So this obviously limits the capacity because, 3 digits of decimal would be 10 to the power of 3, which is 1,000 different numbers. 3 digits of binary is 2 to the power of 3, which is 8. So 0 to 999 compared to 0 to 7, which limits it. But after we learn about binary, I'll talk about the applications of it. But there you go. This the place counting is a bit different than decimal. Instead of ones, tens, hundreds, thousands, it's ones, twos, fours, eights. It goes down halves, fourths, eighths, sixteenths. And of course, that's always following the base concept, 2 to the power of 0, and so on and so forth. And since binary only has 0 and zeros and ones, it's pretty simple and easy to deal with. An excellent starter one, but obviously the only problem is its limited capacity. So let's get on to the fun stuff, which is of course arithmetic. Now, addition is exactly what you would see with decimal. 1 plus 1 equals 0, carry the 1. Now, 1 plus 1 plus 1 equals 1, carry the 1. 1 plus 1 equals 0, carry the 1. 1 plus 1 equals 0, carry the 1. 1 plus 0 equals 1. And so on and so forth with different stuff with binary. And there you go. You just added that number with that number. Now, obviously, you don't know. You don't really know what numbers those are in decimal, since that's all we really understand by nature. But we'll go over conversions after we deal with arithmetic, and then subtraction. Now, subtraction is a lot more difficult, especially borrowing. I mean, you could do borrowing manually, but that gets really complicated, really fast, and especially with large expanses of zeros, which is the example we have here. So what we're going to do is something a little more intrinsic. First, you flush them to the left side, make sure they're exactly the same length, which is why I added that 0 to the left of the bottom term. And then what we do is called applying 2's complement. Now it's called 2's complement because binary is base 2. And if you ever had geometry, a complement is, filling it into the other side. Have the other side of things. So basically what we're going to do, we're going to take the original term and we're going to invert all of the zeros to ones and all the ones to zeros. So we can do that real quick, which of course is really easy. And then, the other thing we have to do, we have to add 1. So now we have 2's complement of our original term. And since we already know addition, adding 1 is pretty easy. Now what we're going to do, we're going to replace our original term with the 2's complement 1, as you see, and then it becomes a simple addition problem. So here we go. We all we know how to add now. So there's your answer. But obviously, adding those to the number wouldn't get the result. So what we have to do is remove the most significant digit, which means the leftmost one. So we're going to remove the leftmost one and the left trailing zeros, and that is our answer to the subtraction problem. Not that bad. Next is multiplication. Again, extremely easy. Now, if you know decimal multiplication, when you're multiplying things more than 1 digit, you have to add, when you multiply the top term by 1 digit of the bottom term at a time. And if you're multiplying a greater, the higher the places you go for multiplying the top term by the bottom term, you have to add more zeros. So the first term, multiplication is really easy since all you're multiplying by 1 or 0. And multiplying by 1 and 0 is extremely easy. So now we multiplied it by 1. Now we have to add 3 zeros since we're shifting over 3 places to the leftmost 1 on the bottom term. And then we just add the thing onto the end of it again because that times 1 is that. Now, regular, like decimal, all we have to do is add these together, and since we know how to add, there's your answer for multiplication with binary. Now, division is fun. Now, first, on the top, you already start with a 0, okay? And what you do, you take the dividend, and you, again, try to see which thing it can go into. Now, obviously, and this doesn't fit into the first, I'm sorry, you flush it to the left first, and as you can see, that doesn't fit into there. It's bigger than the top turn. So what we're going to do is move the answer, where we had to add a 0, since that didn't work. Now, we're going to move this over just a little more, and since, that is longer than the bottom one, that means it is bigger, so now we can add a 1 to the top. And then what we have to do is just a simple subtraction, and since we know how to subtract, I'll just give you the answer. It's 1, 1. Now, we carry down the 1, and we do the exact same thing. Here we go, it goes into 1, so we can add a 1 to our answer. Now notice, in the answer, we are simply just shifting to the left. We get our answers in left to right, and not right to left. Which obviously it isn't normal. Normally, you go right to left in problems. But now we're going left to right. So then, again, all you have to do is subtract, and the answer is 1. You don't even need to do the special thing for subtraction. Then we carry down the 1. Now, obviously, 1, 1, 0 doesn't fit into 1, 1, so we're going to add a 0, and then we're going to carry down the other 0. Now, luckily, it does fit into there, so now we can add a 1 to our answer, subtract those, and luckily, we get a 0. And whenever you do long division, you always stop when you get the 0 as the remainder. So our answer is 1101. Might be long and arduous, but it isn't difficult. So let's go on to the next part, and how to find binary to decimal and decimal to binary. Oh, well, let's start with binary to decimal. Now, as you can see, I added those guides again, so 2 to the power 0, 2 to the power 1. You go all the way through, and there are two ways to do this, the long way and the short way. And the long way works if you're new to binary. The top one would be sort of the long way. So if you use a calculator, you have to type it out and such. So you take each place that has a 1 in it, and you just do that, and you just do that. You do 2 since there's 1 in the 2 to the power in the 4's place. Wait, no, since there's a 1 in the 2's place. Also, but since there's a 1 in the 2 to the power 1 place, you do 2 to the power 1. Plus, there's a 1 in 2 to the power 4, so you do 2 to the power 4, 2 to the power 6, and 2 to the power 7, add that together, and that works. Or the bottom, if you actually know, and have been working for binary for not too long amount of time. It doesn't take that long to notice, especially since it's just each term is multiplied by 2 each time. But, the 1's place, then the 2's place, and the 4's place, then 8, then 16, 32, 64, 128, 256, etc. So if you just look at where the places are, you do 2 plus 16 plus 64 plus 128, which is exactly the same as the top one. But you might not be able to remember that off the top of your head, but don't worry, it doesn't take a lot of time. And you get 210. So 1101010 equals 210 in decimal. Now, decimal to binary, there are two main ways to do this, but I think I'll be showing you the most efficient way. So basically, you divide by 2. You take the original term and you divide by 2, and you get your answer. And after you get your answer, this time we are getting the answer right to left. So you have a 0. What you do with binary is extremely easy. If your answer is a whole number, if it's an integer, then you add a 0 to your answer. And if it isn't an integer, which in binary the only other thing you're going to get with dividing will be dividing by 2 will be something 0.5. So basically that means you take the 0.5 off, but you add a 1 to your answer for that. You add a 1 to your answer for that, then you take the 0.5 off and continue with the thing. So if we just continue here, we have a whole number, add 0. You have a whole number for this one too, you add 0. Next one, you have a whole number, you add 0. So on and so forth. As you can see, our answer slowly culminating. This is a bit slow and tedious if you do it with your calculator, but I think it's the most efficient, especially if you don't know a whole bunch of binary off the top of your head. Now, 27 divided by 2 is, our first weird one. So basically, you saw it's 13.5. So we added a 1, and the next step of our problem, we just reduced it down to 13, we just completely remove the 0.5. So we can continue normal division. And, we continue down, and we continue until we get 0 left behind. So, 1 divided by 2 is 0.5, and if you take the 0.5 off, it's 0. So we're done. So that's the whole thing. We converted 3,456 to 1101100000000, and that's decimal to binary. Now, yeah, that's just your guide, so you can see what the hell we did. Now, useful applications of binary. Encryption is extremely easy with binary, since binary only has 2 possible states: 0, 1, on, off, yes, no, true, false. Whatever you want to do, anything that can have two separate identifiable states can be used to carry a simple message in binary. And speaking of that, now you saw at the beginning where I converted, at the title I converted binary to binary in binary. Binary to binary and binary. Yeah. But basically how you do that, it's ASCII encryption, which is an acronym, not a profane word. But basically you can look up how to do that. It's really simple. But yeah, that's more about it. But electricity, things are either on or off, zeros or ones, and they use that in digital computation. You are watching this on something that uses electronics and Boolean algebra, because your computer obviously operates in Boolean, because your computer operates on electricity, and most computers nowadays use Boolean logic, which is called Boolean. It's named after George Boole, if I'm correct, who created a lot of the great first concepts of it. And a Boolean is basically, true or false. It's something with 2 absolute states. But that's binary. So your computer uses binary, if the voltage going through a chip is negligible, then make it a 0. If it's substantial, it's a 1. And it does a whole bunch of different maths. It does the maths for you. And then I might do a tutorial series on, logic gates and Boolean logic and stuff. But that's, of course, another tutorial series. We're brought to the end of this episode. Next up is ternary, also called trinary. I used to call it trinary, but now that I know it's called ternary, I can call it that. And it's base 3, if you couldn't guess by the name. But thank you again for joining me on this tutorial series. I've been having fun teaching you, as I really enjoy teaching. But I hope to see you next time. And I hope to see you next time.